Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming to you from the Mozaic Works studios, and today I have a very short reaction to news from the C++ world. An article from the newsstack.io starts by saying there's turmoil in the C++ community. In mid-January, the official C++ direction group, which makes recommendations for the programming language's evolution, issued a statement addressing concerns about C++ safety. The whole story is very interesting. The article is actually called "Can C++ be Saved?" Bjarne Stroustroup on ensuring memory safety. And the thing is, where did this happen? It started from a paper from NSA, US National Security Agency, that effectively recommends using programming languages that have basic type safety. So that's ensuring that variables access only sections of memory that are clearly defined by their data types, which includes programming languages like, and they mentioned specifically Java, C#, Rust, Ruby, while effectively removing C++, C and C++ from the equation. And the fundamental argument of NSA is that most of the security issues faced by various operating systems, they mentioned Microsoft, data from Microsoft, and applications, most of the security issues are related to memory safety. And the problem with this, beyond the technical aspects, which we'll discuss in a minute, if US agencies follow course and effectively ask for other languages than C++ for new developments, and perhaps even to switch from C++ to Rust, for example, for the older applications, this will effectively mean that C++ is no longer used in US government services, and this includes the military, this includes various government organizations. And the next thing that happens is historically large companies have followed track with these types of recommendations. I think on one hand because they have government contracts. The US government as a whole has a lot of contracts for software organizations. And on the other hand, because, as a manager, let's say you're the CEO of a large company that also produces software, nobody will tell you that you're doing a bad job if you follow the rules of such agency. As of right now, we don't know whether the NSA paper will have these effects. So we are not sure whether this will change anything in the contracts for other US government agencies, but they might have a large influence. And this is why Bjarne Stroustroup has activated and is actively talking about ways of changing C++ that would help this. But first, let's go in and talk a bit about the technical aspect. So the NSA paper talks specifically about memory-based safety issues. So things like buffer overflow, dangling pointers, these are errors that can be made easily with C++, at least with if you are still using the older ways in C++. And because these mistakes are easy to make, if you're still using memset and memcopy and things like this, and the old string strcopy and other functions like this, then you can very easily introduce issues, safety issues in C++ programs, and that leads to potential for attackers to move in. And I think this has been made relevant due to efforts related to increasing cyber safety, and the fact that this has become a national security issue for many countries, and US, of course, being one of the leaders here. So, in a first paper to respond to this, Bjarne Stroustroup has talked about the fact that memory safety is not the only safety that you need to have. So this is a very good argument. There are other types of things that you need to be aware of. That safety is very different for different types of applications. So there's not only one type of safety, but there are actually more types of safety. It's one thing to do, and this is one of the challenges with C++, right? You can use C++ for embedded software, you can use C++, and that's one level of safety. In embedded systems, you generally have limited memory, limited heap, so you need to be careful there. With other types of software, so another type of software that has been that uses C++ is high frequency trading. And in this case, every millisecond counts. So basically, these are pieces of software that trade on the stock exchange and do it very, very quickly. It's the automated trading. And there is really a struggle for shaving down microseconds. And in that case, of course, you need safety. But these are actually trading, so are calling other things. So maybe they are not as exposed as other types of software, and so on. Of course, you have games. Do games need to be protected? I mean, yes, of course, but to what level? Right? What was the level of security that you need for games? And of course, if you have guidance systems for airplanes or software for medical devices, there you need to have high levels of safety. So indeed, there are different profiles for safety that you need to address, and that's basically what Bjarne Stroustroup is saying. And other things are that he talked about is that the paper is lumping in the same category, C and C++. If you haven't used C++ lately, it's changed a lot. So basically you can write now C++ code that looks a lot like Java. If you are using the STD, the standard library, you have a lot of things there that solve these issues. So you have fewer memory, fewer potential for, or less potential for memory issues, because you'll be using smart pointers. You'll be using fundamentally managed types, only types that are designed for performance as well as for safety and other things. So you can today write quite safe code in C++ if you are using the modern constructs for C++. You can even write functional programming in C++ today, and maybe you know I authored a book about this. It's a topic that's really fun for me. So that's another thing. And so what? But Bjarne Stroustroup understood that it's a problem, because if what I talked about will happen, and if NSA paper is followed by actual action by government agencies and then by large companies, this basically means that C++ will go away. And of course we still, and that's another argument that he talks about, we still have billions of lines of C++. There's a lot of C++ code out there. And it will not be trivial to transform C++ code into another language or to bring it up to par. And now what they recommended until now, and this is what is changing, is that what they recommended is you should have judicious programming technique, language rule, and static analysis. So fundamentally, they said the recommendation until now has been, okay, be careful how you write your code, use tools for static analysis. Problem is that static analysis doesn't cover all the security issues. And Patricia Haas is quoted here from Twitter. The fact that Bjarne caused him to think that you can fix safety in C++ with static analysis shows how completely out of touch they are with security research. Patricia knows really well this domain, both C++ and security, and I agree with her. You cannot fix security issues only with static analysis. In fact, for every application, you should have a threat model, and the language makes it a bit harder, but I've been a fan for a very long time of the approach that you pick a subset of the language and just use that subset, depending on what you're working on. Because C++ is not one thing. C++ is a lot of different paradigms. And every team I've worked with has actually worked with a subset of the language, only not made explicit. So honestly, what I'd really love to see here is the ability to define the subset of language that you work with, and have subsets of language maybe that are fit for various things, like for embedded software and for air control systems and other things like that, for games, because these are very different. And so now they wrote a paper, the direction group, which is Bjarne Stroustroup and a few other people. And because of this NSA document, they are calling to change the C++ language itself to address safety concerns. So now they have changed the stance that you should have only tooling for safety. And what this paper is saying is we now support the idea that the changes for safety need to be not just in tooling but visible in the language, compiler, and library. And this is a very good step forward. What it proposes is packaging several features into profiles defined as a collection of restrictions and requirements that defines a property to be enforced. For example, triggering an automatic analysis. The new changes for safety should be visible such that the safe code session can be named, possibly using profiles, and can mix with normal code. So that's an interesting approach. It would basically mean that you annotate in a way or another pieces of code and you say, okay, this is safe embedded or safe automotive or safe medical or, other things like that. I'm not sure, however, that this can cover, definitely can reduce the risks, but we still have to understand that security is a very different concern from development. So we need to be very careful with these things. And I'm not sure you can make these changes without breaking existing code, which is, I think, what they are hoping for. Improve safety without breaking existing code. Of course, if you decide to annotate and which parts you decide to annotate, it's up to you. Then you can decide how to move on. But will people actually adopt this? Or would you rather rewrite that piece of code in Rust, let's say, which is a modern language, it's new. Bjarne Stroustroup has said that, Rust is not necessarily what, I don't have here the exact quote, but basically said that C++ is still valuable and covers more scenarios than Rust. And what he said is, I think C++ can do anything Rust can do, and I would like it to be much simpler to use. Now, that is to be seen, because Rust has been developing quite fast. So I think this is important. C++ is a very used language. I know a lot of C++ programmers. We organized CPP Europe conference for a number of years already, and we've met a lot of C++ programmers. I like this community. These are some of the most thoughtful people that I have met in this industry. On the other hand, they are also dealing with a lot of language complexity. And I think that adding these profiles will just add another layer of complexity to the language. Personally, I prefer having something like Rust that has sensible defaults, like variables that are immutable and things like that, that you can and memory safety by default and all these kinds of things. And then if you really want performance, you can switch to some other some other profiles, basically. I think this is what's missing in C++, is sensible defaults for now. They kind of are there, but only if you are using the right things. If you're using the STD things, collections and algorithms and everything, then those will ensure you a high level of safety, and the code will actually look quite nice. And really, if you haven't done C++ for a while, try out the new language. It's quite nice. So the improvements have been really good. So I think the big question here is, will this be an inflection point, a point where, due to various decisions made by the organizations that pay money for software development, is it possible that we'll see C++ going away? And I don't have an answer to this question. If I were right now a C++ programmer whose job depends on knowing this language, I would probably look at learning other languages as well, like in the same area, because the problems that C++ solve will still be there. So you'll still need the performance that C++ gives and so on, but maybe you'll need to do it with another language. So maybe you'll need to try out Rust or, I don't know, C#. I'm not sure that C# is the best alternative, but that's really up to the domain you are in. So I would really look at other programming languages, maybe start hedging my bets, but don't take this as advice. Everyone has to think for themselves. It's important though to understand where we are, and what might change in the future. And I hope this will make things clearer for you, or at least visible for you. You have in the description links to the different papers that I talked about and to this article. Make up your own opinion. Let me know in the comments what you think. And until next time, remember to think, design, and work smart.